In the previous video, we made basic overheating protection. Today we're gonna use light sensor and operational amplifier. Okay, so this is the light sensor I'm gonna use. Initially, I planned to control the brightness of the main RGB LED with this sensor. But later I conclude that adding a separate LED will be a better approach. This will serve as preparation for the future eventually. This same circuit will be used to control the brightness of the display once we move to the working with screens. Okay, now let's see how this sensor works. I connected a multimeter to the sensor and I set the multimeter to the resistance measurement. And you can see we have 0.8 kilo ohms and it is changing because the light is changing constantly a little bit. And now we have pretty small resistance because I have a lot of light in here, but when I cover this, you can see the resistance is rising up. Now we have 2k ohms, and now we have 14k, and it's changing constantly. It's not stable, but yeah, when I take out my hand, light is hitting the sensor, and I can also use the small light like this and move it even closer, and you can see we get around 100 ohms only on this sensor. So yeah, this works basically very similar like NTC, but it is sensitive to the light, not to the temperature. Okay, so this is our device. And I'm gonna connect everything somewhere here. So now I will zoom in a little bit so you can see better. Okay, so the easiest way to use this sensor is by connecting LED. I will use a 3mm LED, white LED, but you can choose different one if you like to. I'm gonna place it, let's say, somewhere here, and I'm gonna use resistor 220 ohms. I'm gonna place it like this. And we want a resistor because you saw before that resistance of this can drop near the 0 ohms. It is in the extreme situation, but it is possible, so we wanna have another resistor so our LED will not break. Now let's connect LED to the ground and our light sensor to the VCC and to the resistor like this, and this should work. Okay, LED It's glowing. You can see when I cover the sensor, the brightness of the LED is lower. But there is a lot of problems with this setup. The main problem with this setup is that LED is responding basically immediately with the changes on the sensor. So it's not really practical, because if you will have display and it starts blinking because the changing of the light, it won't be really good to look at this display. It will start flickering. So yeah, we have to do something better than this. Okay, so let's take out our sensor and our resistor. The LED probably can stay where it is, or maybe, you know what, let's take this out also. Okay, we want to take our sensor and place it somewhere, let's say here. I want to connect it to the VCC like this, and now I will take the resistor 47k ohms and I will connect it to the same line where the sensor is, so it is connected with the sensor, and to the ground. Let's say like this. Now I'm gonna take this 15 microfarads capacitor and I will connect it to the same point where the resistor and the sensor are connected, and the minus to the ground. This is our RC filter. It will smooth the reaction of the LED. Okay, now we're gonna use the op amp LM3914. This will be our buffer, and we will connect it somewhere here as high as possible, so we have more space here. Now let's connect the VCC to the op amp like that, and the ground. Like this. Okay. Now we're gonna need NPN transistor, so I will use BC 337 and we will connect this somewhere here. Okay, we're gonna use transistor because we don't wanna stress too much our op amp. We wanna limit the current that is flowing through this. Okay, now we're gonna connect our LED. The minus of the LED will be connected with the collector of the transistor like this. Okay, of course we're gonna need resistor to limit the current flowing to the LED. I will use 220 ohms resistor, and we're gonna connect this to the LED and to the VCC like this. Now let's connect the emitter of the transistor to the ground like this. Okay, this IC has two op amps inside, and one is on the left side and one is on the right side. I think I'm gonna use this one on the right side because it will be easier to connect, I think. And now we wanna use 10K resistor and connect pin number 7 output from the op amp with the base of the transistor like this. Now we want to connect pin number 5 of the op amp. This is a positive input with this point where the sensor, capacitor and resistor are connected together. So okay, so I'm gonna place it right here like this and connect this with this line and connect this. And the last thing, we have to connect pin number 6 with the pin number 7. The negative input with the output. Like this. Okay, so I turned on the circuit and this is not really working. So first I want to check the voltage in this point where the sensor, resistor and capacitor are connected together. Let's see, we have 3.8, 3.7 volts. When I cover the sensor, it dropped down to the 2.9 volts. I think 1 volt and difference is too small. So what I'm gonna do is I'm gonna replace this resistor and I'm gonna use a smaller one. So I'm gonna use 10K resistor. So let's gonna connect this to the ground. Okay. Now let's turn on the circuit. Let's see. We don't have any changes. Okay, so I have problems with that and I needed to do something with the sensor because I have many light sources here because I wanna have good light so you can better see what is going on, and because of that the light sensor wasn't working like it's supposed to. So I covered the sensor from the bottom so it is not catching the light bouncing from every side. It only takes light coming from the top. So it's easier for me to show how it works. And I changed this resistor to 6.8K. And now you can see I can cover this, and the light is turning off. Now I'm gonna turn the light off so you can see even better. I will increase exposure on the camera, so quality of this video will be probably a little bit worse, but it will be easier to show you. Turn the lights off. Okay, I increased the exposure. Now I don't have to even move my finger close, just shade. You can see the light is turning off. So everything is working. Now I connected the scope to the circuit to show you why I used op amp in this case. The yellow channel is connected here. This is the input to the op amp, and the second channel is connected here, where is the output of the op amp. And now when I do something like this, you can see on the yellow channel small jumps, but on the blue one, where is the output, there is a straight line. The op amp is fixing these jumps. You can see here also there is a difference. So yeah, basically it works like a buffer. It's smoothing out the signal. Okay, so this is the circuit we have, and we will use this in the next video. But I wanna also show you something more. I wanna give you a little bonus. I will try to show this quickly. I will not explain too much because it's just a bonus, so you know you can do something like this without MCU. I'm gonna use this IC. This is a dot display driver. It is LM3914, and we will use this to make brightness levels to the LED, so it will not work that smoothly like now, but it will have few levels, and depending on the brightness of the surrounding, the specific level of brightness will be activated. Okay, so I'm gonna use another breadboard. I'm gonna place this IC here like this. Okay, so now let's connect the output from the op amp, pin number 7, to the pin number 5. Here. Now let's connect pin number 2 to the ground. Pin number 3 to the VCC. Okay, now pin number 4 is the driver low end. This I wanna connect to the ground because I wanna LED to turn off completely if we go below the lowest range. So now we have to connect pin number 7 with pin number 6. 7. Okay, now I'm gonna connect the pin number 8 reference adjust and to the ground with the 1.2k ohm resistor, like this. Okay, I'm gonna use a wire and I will connect this line to the ground like this. Okay, so now we're gonna set the brightness levels, and first I will use 4.7k ohm resistor and I will connect it to the pin number 10 and somewhere here. Now I'm gonna use 2.2k ohm resistor and I will connect this to the pin number 11 and to the same point as this resistor, so they are all connected together. And I will make another last level. It will be with 1k ohm resistor. I will connect it to the 12 pin, and again they all are connected together here. Okay, now let's take out our, let's turn off this. Let's take out our LED and let's connect it right here. We're gonna connect this side of LED to the VCC like this. It's really hard to show this because the difference is really small when in the brightness, but I will try. You have 3 levels now. Let's see. It's turning off. Oh, you can see now this level is changing and now it's turning off. It's not that smooth anymore. I will show you on the scope, maybe it will be easier to see. Okay, so still it was a little bit hard to show, so I've changed the resistors. The lower one is 220 ohms, this one is 470, and this one I didn't change this one. So now we can see the steps a lot better, you can see, and on the scope you can see the steps. We don't have the curve, but we have steps. So yeah, this is how it works. Pretty cool. Okay, now you know how to use light sensor. In the next video we will start using MCU. We will start small with 80 tiny 13